July 21, 1937, Springfield Armory, Massachusetts. The proof testing range echoed with a sharp crack as the first machine-produced M1 Garand rifle fired its final test round. Chief Engineer John Garand stood beside Army Ordnance inspectors, watching as technicians examined the weapon. Function test, passed. Accuracy test, passed. The rifle that would be declared the greatest battle implement ever devised by General George Patton had just cleared for delivery. Production rate, 10 rifles per day. The United States Army needed hundreds of thousands. War clouds gathered over Europe. Germany rearmed at frightening speed. Japan pushed deeper into China. And America's arsenals could produce just 10 semi-automatic rifles per day, using machinery and methods designed for an entirely different era of warfare. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from. Today, the problem wasn't John Garand's design. After 17 years of development, the M1 rifle represented the most advanced infantry weapon on Earth. It was the only nation's standard-issue semi-automatic rifle, a gas-operated marvel that could fire 8.30-06 rounds as fast as a soldier could pull the trigger. While German soldiers worked bolt actions between each shot, American troops would simply aim and fire. The mechanical advantage was overwhelming. But mechanical advantage meant nothing if you couldn't build the rifles fast enough to arm your soldiers before war arrived. The M1 Garand wasn't just revolutionary in its design. It was revolutionary in its complexity. Every previous American service rifle, the Springfield M, 1903, the Krag Jorgensen before it, even the Springfield muskets of the 1800s, were fundamentally simple machines. A bolt-action rifle has perhaps 50 parts, most machined from solid steel using straightforward operations: drill a barrel, mill a receiver, cut threads, polish surfaces. The M1 Garand contained 72 precisely machined components that had to fit together within tolerances, measured in thousandths of an inch. The receiver alone required over 100 separate machining operations. The operating rod, gas cylinder, and bolt assembly demanded precision that pushed 1930s manufacturing technology to its absolute limits. And the rifle's semi-automatic action meant that any deviation, any imperfection, any tolerance stack-up would cause jams, misfires, or catastrophic failures. Springfield Armory in 1937 was a facility designed to build bolt-action rifles. Founded in 1794 by George Washington, the Armory had spent 143 years perfecting the manufacture of weapons that previous generations of Americans had carried into battle. The machinery, the tooling, the methods, everything reflected that heritage. Skilled. Machinists worked individual components on lathes and mills that had been cutting steel since before the Civil War. When John Garand submitted his first production requirements, Springfield Armory's superintendent nearly wept. The M1 required specialized dies for forging the receiver from high-carbon steel. It required multi-axis milling machines that didn't exist in the Armory's shops. It required heat-treating furnaces capable of precise temperature control across multiple stages. It required inspection equipment that could measure tolerances far beyond what bolt-action rifles demanded. Most critically, it required a complete reconceptualization of how rifles were manufactured. Traditional gun-making was a craft. A master machinist would take responsibility for a single rifle, machining and fitting each component until the weapon functioned perfectly. Every M1903 Springfield was essentially a custom build, with parts fitted by hand to match each individual receiver. This approach produced magnificent rifles, accurate and reliable, but it was impossibly slow for mass production. The M1 Garand demanded industrial production at automotive scales. Not craft, but mass manufacturing. Not individual rifles, but assembly lines. Not skilled artisans, but specialized workers performing repetitive operations with machine tool precision. The problem was, nobody at Springfield Armory knew how to do that. September 1937 marked the first deliveries to the Army. 945 rifles total. Soldiers who received these early M1s treated them like sacred objects. Here, finally, was the rifle that would give American infantry fire superiority over any enemy. Semi-automatic operation meant a trained soldier could fire 40 to 50 aimed rounds per minute, compared to the 10 to 15 rounds possible with bolt-action rifles, like the German Kar98s. The mathematics of infantry combat shifted dramatically. A squad of 8, American riflemen with M1 Garands could put out more firepower than a platoon of 30 German soldiers with Mauser bolt actions. In close quarters fighting, that advantage became overwhelming. During later engagements like Hill 609 in Tunisia, American patrols would encounter German units at close range and simply annihilate them before the Germans could work their bolts for second shots. But in September 1937, those future victories were theoretical. The Army needed to fully equip itself, plus build war reserves for mobilization. The requirement: at least 156,000 rifles by December 1941. Springfield Armory was producing 10 per day. At that rate, full equipment would take 42 years. The criticism was immediate and brutal. Military conservatives who favored bolt-action rifles seized on the production problems as proof that semi-automatic rifles were impractical. Some officers openly advocated cancelling the M1 program and returning to M1903 Springfield production. Congressional committees demanded answers about costs and delays. Newspaper editorials questioned whether the Army had wasted years and millions of dollars on a rifle too complicated to actually manufacture. John Garand faced the worst of it. The soft-spoken Canadian immigrant, who had devoted his adult life to creating this rifle, watched as critics dismissed his life's work. Some called the M1 impossible to mass produce. Others claimed specific components couldn't be manufactured at all. Military board meetings featured officers confidently explaining which parts were too difficult for industrial production, which tolerances were impossibly tight, which processes would never work at scale. Garand said nothing publicly, but in the Springfield Armory machine shops, he set to work, proving every critic wrong. The receiver was the heart of every rifle. This precisely machined steel component housed the bolt, contained the gas system, and formed the structural backbone of the weapon. For the M1 Garand, the receiver had to be forged from high-carbon steel, then heat-treated to achieve Rockwell hardness of D59 to D67, then machined through over 100 separate operations to create the complex internal geometry the semi-automatic action required. Critics said it couldn't be done at production rates. Garand tooled the receiver manufacturing himself. The process began with forging dies. Garand designed dies from hardened tool steel, precisely milled to shape molten steel into the rough receiver form. 3-head milling machines cut 3 dies simultaneously, because forging wore out dies quickly and production couldn't stop to remake them. The dies themselves were masterpieces of precision tooling, cut to tolerances that previous generations of gun makers would have considered impossible. Forging required heating steel bars to 1600 degrees Fahrenheit, then hammering them into the dies with tremendous force. The operation had to be fast, before the steel cooled and lost malleability. Too slow, and the steel wouldn't flow into die details. Too fast, and the force would crack the die. Springfield Armory workers developed a rhythm, placing hot bars, dropping the hammer, extracting the forging, all in synchronized movements that looked like industrial choreography. The forged receivers then went to heat treatment. This was where skeptics said mass production would fail. Heat treating wasn't new. Blacksmiths had been hardening steel for millennia. But the M1 receiver required precise carburization, adding carbon to the steel surface in exact amounts, followed by oil quenching, then tempering at 480 degrees for exactly 1 hour. The result had to be consistent across every receiver, creating a hardened shell with a tough, ductile core. Get it wrong, and receivers would crack under firing stresses or wear out prematurely. Get it right, and the M1 would survive tens of thousands of rounds and decades of service. Springfield Armory installed pyrometers, precision temperature instruments, in every heat-treating furnace. Workers learned to read temperatures to the degree, control atmosphere composition, time each stage exactly. It was metallurgical science applied at industrial scale, requiring workers to understand material properties most machinists had never considered. Then came machining. The hardened receiver had to be cut, drilled, tapped, and milled to create the complex internal surfaces the bolt and operating rod would interact with. Brown and sharp milling machines cut guide slots using multiple cutting wheels simultaneously. 4-head gang milling machines worked on 4 receivers at once, each head cutting identical operations so tolerances remained consistent. This was where Garand's genius became apparent. He hadn't just designed a rifle, he'd designed a rifle that could be manufactured. Every component, every dimension, every tolerance had been chosen not just for mechanical function, but for production feasibility. The receiver could be machined on existing equipment, adapted to new purposes. The bolt could be cut using standard tooling. The operating rod required precision, but precision within reach of skilled machinists using proper fixtures. Colonel James Hatcher, an Army Ordnance officer, addressed critics in a 1939 lecture at the Army Industrial College. Some poorly informed critics of the M1 rifle have pointed out several components as being impossible or very difficult to make. It may be of interest to you to note that the operations on these parts were tooled by Mr. Garand himself, and to the confusion of the critics, in each instance these are the operations being produced at the highest rate and with the least difficulty. Production rates climbed, 10 rifles per day in September 1937, 20 per day by March 1938, 80 by July 1939, 100 by September 1st, 1939, the day Germany invaded Poland and began World War II in Europe. But even 100 rifles per day was catastrophically insufficient. Germany had begun the war with 1.5 million soldiers armed with Kar98s rifles. Italy fielded 800,000 with Carcano bolt actions. Japan had mobilized millions, and America could build 100 semi-automatic rifles per day. The January 1938 memo from the Chief of Ordnance to Springfield Armory's commanding officer was polite but urgent. It is most gratifying to note that the semi-automatic rifle is now in production. Reports being received from the using troops to whom the production rifles have been issued are most enthusiastic as to its performance. The demand from troops to be equipped with this important weapon is very urgent, and every effort should be made to fill current orders, promptly. Manufacturing methods should be restudied so as to get increased production and to cut costs in every way possible. Translation. Figure it out, fast. The problem went beyond individual component manufacturing. Springfield Armory was still essentially running a craft shop at slightly higher scale. Receivers moved from forging to heat treatment to machining in batches. Barrels were rifled individually. Stocks were carved on Blanchard lathes one at a time, then hand-inletted to fit each receiver. Every part moved through the facility in its own timeline, creating bottlenecks where workers waited for components while other operations ran overtime. The armory needed to be transformed from a workshop into a factory, not evolutionary improvement, but revolutionary reconceptualization of every step from raw steel to finished rifle. That transformation began in earnest in 1940, when everything changed at once. Adolf Hitler's Wehrmacht had conquered Poland, Denmark, Norway, the Netherlands, Belgium, and France in less than a year. The British Army evacuated from Dunkirk, leaving most of its equipment behind. The Soviet Union signed a non-aggression pact with Germany. Italy entered the war. The entire world, except America, was either at war, conquered, or about to be invaded. Congress approved a 250% budget increase for Springfield Armory in 1940. With that money came authorization to expand facilities, install modern machinery, hire thousands of additional workers, and fundamentally modernize every aspect of production. The workforce exploded. Springfield Armory employed approximately 7,500 workers in 1945, times more than just years earlier. By 1942, that number would reach 14,000. By the peak of production in 1944, nearly 15,000 people worked 3 shifts around the clock. Women flooded into the armory in unprecedented numbers. Before the war, women worked primarily in administrative roles. Now they operated lathes, milling machines, forges, and heat-treating furnaces. The women ordnance workers, nicknamed WOWs, performed every aspect of M1 production, from heavy forging to delicate stock making. By war's end, 43% of Springfield Armory's workforce was female. But workers alone couldn't solve the production crisis. The armory needed better processes, better machinery, better methods. The transformation required rethinking how rifles were manufactured from first principles. The Blanchard lathe problem exemplified the challenge. Thomas Blanchard had invented his gun stock duplicating lathe in 1819 at Springfield Armory. The machine used a follower wheel to trace a master pattern, while cutting blades reproduced that shape in a blank piece of wood. It was brilliant for its era, allowing semi-skilled workers to produce stocks that previously required master craftsmen. By 1930, Blanchard lathes were still excellent tools, but they produced one stock at a time, and each stock required hand inletting to create precise voids for the barrel and receiver. Skilled woodworkers spent hours per stock, carefully chiseling and fitting until the rifle assembled properly. Springfield Armory engineers developed improved Blanchard lathes that cut 3 stocks simultaneously, running faster and more precisely than the century-old designs. They automated the inletting process, using milling machines to cut barrel and receiver channels in coordinated sequences, vacuuming wood chips as they worked. The exterior shape could be cut and sanded by machine. The interior voids could be milled by machine. Only final fitting required handwork, and even that was minimized through improved tolerances. The results were dramatic. Stock production that had taken hours per unit dropped to minutes per unit. Quality improved because machine operations were consistent. And workers who had spent years learning woodworking could be retrained in weeks to operate automated equipment. Similar innovations cascaded through every production step. N-block clips, the 8-round magazines that fed the M1, were stamped from spring steel in multi-thousand-unit runs rather than machined individually. Multi-head gang milling machines worked on components in parallel. Dies and fixtures were designed for rapid changeover. Inspection equipment was developed to check tolerances quickly and accurately. Most importantly, Springfield Armory embraced assembly line principles. Components no longer moved through the facility in chaotic batches. Instead, production was synchronized so parts arrived at assembly stations in coordinated flows. Receivers, barrels, bolts, operating rods, gas cylinders, triggers, stocks, all converged on assembly lines, where specialized teams built complete rifles in steady progression. Production rates reflected the transformation. 200 rifles per day by January 1940, 600 per day by January 1941. The Army was fully equipped with M1 Garands by the end of 1941, just as Pearl Harbor threw America into total war. Then came the war years, when production demands escalated beyond anything peacetime planners had imagined. By January 1942, Springfield Armory produced 1,103 rifles per day. The facility operated around the clock, 3 shifts, 7 days per week. Workers arriving for their shifts walked past finished rifles stacked in crates ready for shipment to training camps, to ports, to theatres of war around the globe. The armory wasn't alone. Winchester Repeating Arms Company received contracts to produce M1s, using tools and specifications provided by Springfield. By December 1940, Winchester delivered their first rifles. By June 1945, Winchester had produced over 513,880 M1 Garands. But the real miracle was happening back at Springfield. January 1944, peak production month. Springfield Armory manufactured 122,001 M1 rifles in 31 days. That translated to 3,936 rifles per day. 164 rifles per hour. Nearly 3 rifles every minute. From 10 rifles per day in 1937 to 3 rifles per minute in 1944. A 400-fold increase in 7 years. The cost dropped even more dramatically. Early production M1s cost approximately $200 each, equivalent to over $31,000 in today's money. By 1945, the cost had fallen to $26 per rifle, approximately $430 today. The cost per rifle dropped 97% while quality and performance improved. This wasn't just manufacturing efficiency, it was an industrial revolution compressed into a single product at a single facility, driven by necessity and executed by thousands of workers who understood their mission with absolute clarity. Every rifle they built meant an American soldier had fire superiority over the enemy. Every day of production meant hundreds more troops, equipped with the weapon General Patton would call magnificent. Every efficiency gained meant the difference between victory and defeat on battlefields, from North Africa to Normandy to the Pacific Islands. The M1 Garand's dominance in combat validated every hour spent perfecting production. At Hill 609 in Tunisia, American patrols armed with M1s encountered German units at point-blank range. The Germans, armed with Kar98s bolt actions, were annihilated before they could cycle their bolts for follow-up shots. The battle lasted seconds. The outcome was never in doubt. In the Pacific, Japanese commanders learned to fear the sound of M1 Garands, banzai charges that had succeeded against Chinese troops, with bolt actions failed catastrophically against American Marines who could fire 8 rounds in rapid succession. The wall of semi-automatic fire simply stopped human wave attacks cold. Japanese tactical doctrine had to adapt, abandoning suicide charges in favor of defensive positions because charging into M1 fire was guaranteed death. German soldiers captured M1s whenever possible, not to use them. Ironically, the M1's en-bloc clip system meant captured rifles couldn't be reloaded without American ammunition clips. But to understand how the Americans achieved such devastating fire superiority, German intelligence reports described American infantry as extraordinarily well armed and noted that German bolt-action rifles were inadequate in close-quarters combat against semi-automatic weapons. The firepower advantage was mathematical and brutal. A typical American infantry squad with 8 M1 armed riflemen could deliver 320 to 400 aimed rounds per minute. A German squad with 8 Kar98s rifles could deliver 80 to 120 rounds per minute. In any engagement where both sides could see each other and return fire, Americans had a 3 to 1 to 4 to 1 advantage in deliverable firepower. That advantage came from John Garand's design, but it only mattered because Springfield Armory solved the production problem. The rifle was magnificent. The production system that delivered over 4 million of them was equally magnificent, though far less celebrated. Part 2. The M1 Garand production miracle continued. The transformation of Springfield Armory revealed something profound about American industrial capacity. When the nation needed rifles desperately, when every week of delay meant soldiers training with obsolete weapons, the Armory didn't just work harder, it reimagined what was possible. The receiver forging operation became a case study in innovation under pressure. Early production had used single-action drop forges, massive hammers that fell once, shaped the steel, then required manual repositioning for the next blow. The process was violent, imprecise, and slow. Dies wore out quickly from the repeated impacts. Receivers emerged from forging with inconsistent dimensions that required extensive machining to correct. By 1942, Springfield had installed progressive forging systems. Instead of one hammer blow, receivers moved through multiple forging stations in sequence. The first station created the rough shape, the second refined dimensions, the third established final geometry. Each station used dies specifically designed for that step, optimizing force and precision. The steel flowed more uniformly, creating receivers with consistent dimensions that required less corrective machining. Die life improved dramatically. Instead of wearing out after a few hundred forgings, progressive dies lasted for thousands. Production engineers calculated that every hour of die-making time saved hundreds of hours of receiver machining time. The mathematics of mass production became clear. Invest in better tooling, and every subsequent operation becomes faster and more precise. Heat treatment underwent similar revolution. Early M1 receivers went to heat treatment in batches, loaded into furnaces that might contain dozens of parts with varying heat exposure depending on position. Parts near the furnace walls heated differently than parts in the center. Temperature gradients created hardness variations that inspection caught but couldn't prevent. The solution was continuous feed heat treatment. Receivers moved through furnaces on conveyor systems, spending precisely calculated time in each temperature zone. Carburization occurred in atmosphere-controlled chambers, where carbon content could be regulated within narrow limits. Oil quenching happened in precisely timed immersion. Tempering occurred in separate furnaces calibrated to 480 degrees Fahrenheit plus or minus 5 degrees. The result was receivers with uniform hardness, minimal warping, and predictable properties. Reject rates dropped from 15% to under 3%. More importantly, receivers that passed inspection performed identically, creating rifles with consistent reliability and longevity. Barrel production faced its own challenges. Rifling a barrel involves cutting spiral grooves inside the bore, giving bullets spin that stabilizes flight. Traditional rifling used a broach, a cutting tool pulled through the barrel in a single pass, cutting all grooves simultaneously. The process was precise but slow, requiring careful setup and producing swarf, metal chips that had to be cleaned meticulously from the bore. Springfield Armory adopted button rifling for high-volume production. Instead of cutting grooves, a hardened carbide button was pushed through the barrel under tremendous pressure. The button's profile had raised lands that displaced steel, forming grooves through cold working rather than cutting. The process was faster, produced no swarf, and created smoother bore surfaces that improved accuracy and barrel life. Barrel production rates jumped from dozens per day to hundreds per day. The barrels themselves performed better, with more uniform rifling and tighter tolerances. Shooters noticed. The M1 Garand earned a reputation for accuracy that exceeded many bolt-action rifles, partially because of superior barrel manufacturing. Stock production became almost entirely automated. The improved Blanchard lathes running in 1944 could cut and sand 3 stocks simultaneously in the time old lathes took to rough cut one. But cutting was only part of the process. Each stock required a metal butt plate, sling swivels, and a handguard. Installing these components had been manual assembly work. Springfield developed specialized fixtures that held stocks in precise positions while workers installed hardware. The fixtures had spring-loaded clamps that positioned the stock correctly, drill guides that ensured screw holes aligned perfectly, and stops that prevented over-tightening. A skilled worker could fully outfit a stock in under 2 minutes using the fixtures. Without them, the same work took 10 minutes and produced inconsistent results. Quality control evolved from inspection to process control. Early production relied on inspectors catching defects after parts were made. If a machinist's setup drifted out of tolerance, dozens or hundreds of bad parts might be produced before inspection caught the problem. Those parts had to be scrapped or reworked, wasting time and material. Process control focused on preventing defects rather than catching them. Machinists used go-no-go gauges to check dimensions continuously while working. Setup specialists verified machine calibration before production runs. Statistical sampling caught tolerance, drift before significant numbers of parts were affected. The goal shifted from detecting bad parts to ensuring good parts never became bad parts. The reject rate for completed rifles dropped below 1% by 1943. Parts interchangeability improved so dramatically that rifles could be assembled from randomly selected components without hand-fitting. A receiver from Monday's production could accept a bolt from Wednesday and a barrel from Friday, all fitting together within specifications. This interchangeability was crucial for field maintenance. When rifles broke in combat, armourers could replace damaged components without custom fitting. A cracked receiver could be swapped for a spare. A worn barrel could be replaced in minutes. The rifle was designed for industrial production, but that design philosophy extended to industrial-scale repair and maintenance. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The human element of this production miracle deserves recognition that history has largely denied. While John Garand received medals and honours, while General Patton's quote became famous, the 14,000 workers who actually built the rifles remained anonymous. They worked in conditions that would horrify modern safety inspectors. Forging operations filled shops with heat and noise. Molten steel splashed from dies. Hammer blows shook floors. Workers wore leather aprons and gloves, but protection was minimal by today's standards. Burns were common. Hearing damage was universal. Industrial accidents happened regularly enough that the armory maintained a full-time medical staff. Yet they came to work every day, 3 shifts around the clock, understanding that every rifle mattered. Letters from soldiers in combat zones were posted in the shops. "Your rifles saved our lives at Guadalcanal." "The M1 never failed us in North Africa." "Keep building them. We need more." Workers, read those letters and return to their lathes and forges with renewed purpose. The women ordnance workers faced particular challenges. Many had never worked in industry before the war. They arrived at the armory with no mechanical experience, learned to operate complex machinery in weeks, and performed at levels equal to male workers who had years of experience. Some faced skepticism from male co-workers who doubted women could handle heavy industrial work. They proved doubters wrong through simple competence. Rose Lieberman operated a forging press in Building 12. She worked the graveyard shift, midnight to 8 in the morning, 5 days a week throughout the war. In a 1944 newspaper interview, she was asked about her work. "I'm making rifles, so my brother in the Pacific has the best weapon in the world," she said. "Every receiver I forge might be the one that saves his life. You think about that, you don't get tired." Survived combat on Saipan and Okinawa, carrying an M1 Garand with a receiver forged in January 1944. Whether his sister made that specific receiver is unknowable, but the principle she articulated connected every worker to every soldier. They were on the same team, fighting the same war, just using different tools. The pace was relentless. 3,936 rifles per day meant 164 per hour, which meant nearly 3 per minute flowing off assembly lines continuously. Workers developed rhythms, movements that became automatic through endless repetition. Install stock, attach barrel, insert bolt, test headspace, check function, next rifle. Assembly workers could build a complete M1 Garand in under 12 minutes by 1944. That included installing all components, checking timing, testing trigger pull, verifying safety function, and preparing the rifle for final inspection. 12 minutes from loose parts to functioning weapon. The assembly workers weren't just fast, they were precise. Rifles had to pass function tests without adjustment or rework. Final inspection was unforgiving. Every rifle was test-fired with proof loads, ammunition loaded to higher pressures than standard to verify the rifle could handle stress. Inspectors checked headspace with precision gauges, ensuring the bolt locked properly without excessive clearance. They verified gas system function, tested the safety, checked trigger pull weight, examined every surface for cracks or defects. Some defects could be corrected, a rough trigger polished, a gas cylinder adjusted. Major defects meant disassembly and component replacement. Catastrophic defects meant scrapping the receiver and starting over. The standards never relaxed. No rifle left Springfield Armory unless it met specifications completely. The quality obsession served purpose beyond pride. Soldiers trusted their lives to these rifles. In jungle humidity and Pacific saltwater, in North African sand and European winter, the M1 Garand had to function without fail. A jam in combat meant death. A broken firing pin meant a soldier unable to return fire. A cracked receiver meant injury from a catastrophic failure. Springfield Armory understood this with absolute clarity. The worker who machined a bolt was responsible for a soldier's life. The inspector who approved a rifle was responsible for mission success. The maintenance technician who calibrated machines was responsible for winning the war. Everyone understood their role's importance. The pressure created innovation. Workers developed techniques that weren't in manuals. A machinist discovered that cutting spiral grooves in the bolt face improved gas seal without requiring specification changes. The modification was tested, approved, and incorporated into production. Another worker found that angling oil grooves in the receiver reduced friction without weakening the structure. Testing confirmed improvement. The change became standard. These weren't management-directed innovations. They came from workers who understood the product intimately and saw opportunities for improvement. Springfield Armory had suggestion programs, but most innovations simply appeared on the shop floor, workers modifying procedures that produced better results. Engineering would investigate, validate the improvement, then disseminate it across all shifts. The culture rewarded practical knowledge over formal credentials. A worker with 8th grade education who could improve production was valued more highly than an engineer with university degrees who couldn't solve practical problems. John Garand himself embodied this principle. He had no formal engineering education, just mechanical aptitude and relentless problem-solving. By 1943, Springfield Armory had become the most efficient rifle factory on Earth. German Mauser production, despite impressive numbers, required more man-hours per rifle and produced weapons inferior in firepower. Soviet Mosin Nagant production achieved high volume through crude manufacturing that sacrificed precision for speed. British Lee Enfield production was sophisticated but couldn't match American output. Only America armed its entire military with semi-automatic rifles as standard issue. Only America produced over 4 million of them in under 8 years. Only America reduced costs while improving quality. And only Springfield Armory demonstrated that precision manufacturing could be scaled to automotive production levels without sacrificing performance. The combat results validated everything. In Europe, American infantry outfought German troops in engagements where both sides had cover and could return fire. The M1's fire superiority negated German advantages in tactics and experience. A Wehrmacht veteran captured in France told interrogators, "We feared your rifle more than your artillery." Artillery, you could hide from. Your semi-automatic rifles meant we couldn't show ourselves without being shot immediately. The Pacific Campaign showcased the M1's dominance even more dramatically. Japanese tactics relied heavily on night infiltration and close-quarters combat where bolt-action rifles were least effective. But the M1 Garand excelled in exactly those conditions. American Marines could fire rapidly in any direction without working bolts. The en-bloc clip's capacity meant reloading less frequently under stress. At Guadalcanal in 1942, the 1st Marine Division's after-action reports praised the M1 repeatedly. The semi-automatic rifle proved invaluable in jungle combat. Japanese infiltration tactics were repeatedly broken by rapid, accurate fire from Marines who could engage multiple targets without losing their firing position to work a bolt. The legendary Marine gunnery Sergeant John Basilone earned the Medal of Honor at Guadalcanal while armed with a machine gun, but his rifle platoon carried M1s. In later interviews, He credited the Garand with giving Marines the firepower advantage that stopped Japanese attacks. "Give me 8 Marines with M1s over 20 enemy with bolt actions any day," he said. "The math isn't close." The math truly wasn't close. In documented small unit actions, where American and German infantry engaged at ranges under 200 yards, American forces consistently achieved kill ratios above 2-to-1, despite rough parity in numbers and tactical position. The M1's fire superiority was the measurable difference. At longer ranges, the advantage narrowed because accuracy mattered more than fire rate. But most infantry combat occurred at ranges where rapid fire was decisive. Soldiers who could put 8 rounds on target in seconds overwhelmed enemy who fired once, then had to work a bolt while under fire. The production numbers told America's industrial story. Between 1937 and 1945, Springfield Armory manufactured 3,526,922 M1 Garands. Winchester produced 513,880. Combined total, 4,040,802 rifles. 4 million rifles in 8 years. But the real achievement wasn't the quantity. It was maintaining quality while achieving quantity. Every single rifle worked. Every one met specifications. Every one gave American soldiers the firepower advantage that helped win the war. The cost was manageable. At $26 per rifle by 1945, the entire production run cost roughly $105 million, equivalent to about $1.7 billion today. For comparison, a single Iowa-class battleship cost $110 million in 1945 money. America bought 4 million rifles for less than the cost of one battleship. The return on investment was incalculable. How do you value fire superiority in every infantry engagement? How do you price the psychological advantage of knowing your rifle outperforms the enemy's? How do you calculate lives saved because American soldiers could shoot faster and more accurately? General Patton's famous quote, "The M1 rifle is the greatest battle implement ever devised," wasn't hyperbole. He understood that infantry combat ultimately came down to rifles firing at each other. Whoever could deliver more accurate fire faster won. The M1 gave American infantry that advantage in every engagement. But Patton's quote should be expanded. The greatest battle implement ever devised was also the greatest production achievement ever executed. The rifle and the manufacturing system that built it were equally important to victory. By May 1945, Germany surrendered. Production slowed immediately. The frantically urgent pace of wartime manufacturing relaxed as victory in Europe removed half the enemy. Japan's surrender in August 1945 ended the need for more rifles entirely. Contracts were cancelled. Workers were laid off. The 3-shift, around-the-clock operation that had defined Springfield Armory for 4 years shut down. The post-war period saw Springfield transition from manufacturing to maintenance. Over 500,000 M1 Garands needed rebuilding, refurbishment, or repair. Combat wear, improper maintenance, and damage had left many rifles in need of work. Springfield established overhaul operations that would continue for years, rebuilding rifles to factory specifications using new parts manufactured specifically for repairs. The Armory's workforce shrank dramatically, from 14,000 workers in 1944 to fewer than 3,000 by 1947. Many of the women ordnance workers left voluntarily, returning to pre-war lives or starting families. Others wanted to continue but faced employers who preferred hiring men returning from military service. The war had demonstrated women's capability in industrial work, but peacetime society wasn't ready to fully embrace that reality. John Garand continued working at Springfield Armory until his retirement in 1953. He received numerous awards, including the Medal for Meritorious Service in 1941 and the Medal for Merit in 1944. Congress debated granting him $100,000 in recognition of his contributions, but the bill never passed. Garand had signed away all patent rights to the government, receiving only his modest civil service salary throughout his career. He never expressed regret about the financial sacrifice. In a 1951 interview, he was asked if he resented not profiting from his rifle's success. "I did my job," he said simply. "The government paid me fairly for my time. The rifle worked. Soldiers came home because of it. That's enough." The M1 Garand remained America's standard service rifle through the Korean War. Between 1952 and 1957, Springfield Armory resumed production, building an additional 637,420 rifles. International Harvester and Harrington and Richardson also produced M1s under contract, adding another 766,000 rifles. Total M1 production across all manufacturers and all years, 5,468,772 rifles. The M1's replacement, the M14 rifle, was essentially an updated Garand design with selective fire capability and a detachable 20-round magazine. It entered service in 1957, officially ending the M1's reign. But many M1s remained in service through the Vietnam War in specialized roles. The rifle John Garand, designed in the 1920s, remained relevant into the 1970s. Today, the M1 Garand enjoys legendary status among firearms enthusiasts and collectors. Original World War II-era rifles command premium prices. The Civilian Marksmanship Program distributes surplus M1s to qualified civilians, keeping the rifle alive in shooting competitions. Veterans' honor guards use M1s in ceremonial duties. The distinctive ping of the N-block clip ejecting remains one of the most recognizable sounds in firearms history. But the rifle's true legacy isn't in collectors' safes or shooting ranges. It's in what the M1 represented: America's ability to innovate under pressure, to scale precision manufacturing to mass production, to solve problems that experts claimed were impossible. When Springfield Armory faced the challenge of producing 10 times more rifles than previous capacity, they didn't just work harder. They transformed themselves into a modern manufacturing facility. When critics said components couldn't be mass-produced, John Garand designed the tooling himself and proved them wrong. When war demanded 4,000 rifles per day, the Armory reorganized everything to deliver 4,000 rifles per day. The M1 Garand wasn't just the greatest battle implement ever devised. It was proof that American industrial capacity, properly focused and adequately resourced, could accomplish anything. The same principles that built M1s at scale would later build Liberty ships, B-17 bombers, Sherman tanks, and entire fleets of warships. The arsenal of democracy didn't just outproduce the Axis powers. It outproduced them while maintaining quality, reducing costs, and continuously improving. Springfield Armory closed its doors permanently in 1968, ending 174 years of continuous operation. The buildings are now a National Historic Site, preserved to show future generations where American small arms were designed and built. Visitors can walk through the shops where M1s were manufactured, see the machinery that forged, and receivers and rifled barrels, understand the scale of the operation that armed American forces for 3 wars. But the real monument to Springfield Armory isn't the preserved buildings. It's the millions of M1 Garands that still exist, functioning perfectly 7 decades after manufacture. Every rifle is a testament to the workers who built it with care and precision. Every one represents a soldier who carried it into combat, trusting his life to its reliability. Every one demonstrates what American manufacturing could achieve when the stakes were highest. The story of the M1 Garand is often told as the story of John Garand's brilliance, and he was brilliant, no question. His design was revolutionary, elegant, and effective. But the rifle alone wasn't enough. The production system mattered equally. The 14,000 workers mattered equally. The engineers who designed tooling mattered equally. The inspectors who maintained standards mattered equally. Victory in World War II required millions of individual contributions, from soldiers fighting to factory workers building to farmers feeding to scientists inventing. The M1 Garand production story exemplifies how those contributions interconnected. Soldiers needed weapons. Workers built weapons. The weapons worked because workers built them properly. Soldiers won battles because the weapons worked. Every link in the chain was essential. Modern manufacturing has advanced far beyond 1940s technology. Computer-controlled machines achieve tolerances Springfield Armory workers would consider impossible. Automated assembly lines require minimal human intervention. Quality control uses sensors and software rather than skilled inspectors with gauges. But the fundamental principle remains unchanged. Building complex machines at scale requires solving countless small problems, continuously improving processes, maintaining standards without compromise, and understanding that every component matters. Springfield Armory figured that out through necessity and executed it through determination. The M1 Garands production story doesn't have a simple hero or a dramatic breakthrough moment. It's a story of systematic improvement, of workers learning and adapting, of engineers solving problems one at a time, of an organization transforming itself because failure wasn't acceptable. It's not as cinematic as battlefield heroics or as dramatic as scientific breakthroughs, but it's equally important to understanding how America won World War II. The soldiers who carried M1s into combat deserved weapons that wouldn't fail. The workers who built those weapons ensured they wouldn't. That's the real story. Not one genius inventor or one revolutionary innovation, but thousands of people doing their jobs with excellence every single day for years. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.